Coming up on SpaceTime, a giant black hole destroys a massive star, a new window on the X-ray cosmos, and astronomers find a hot Jupiter, or is it a brown dwarf, hotter than the surface of our Sun? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have been examining the ripped-apart remains of a once giant star that was torn apart and discarded by a supermassive black hole. NASA's Chandra X-ray Space Telescope, together with the European Space Agency's XMM Newton Space Observatory, have been examining the stellar murder scene, specifically examining the amount of nitrogen and carbon found near the black hole. Astronomers think that these were created inside the star before it was ripped apart as it ventured too close. The study's lead author John Miller says the observations are showing the guts of what used to be a star. The elements left behind are clues astronomers can follow to help them figure out what sort of star met its demise in this stellar murder case. Stars being destroyed by black holes are referred to as tidal disruption events. That's because it's the immense gravitational forces of the black hole which physically rip the star apart right down to its subatomic level. And astronomers have found many examples of tidal disruption events in recent years. They usually cause a flare often seen in optical and ultraviolet light as well as X-rays as the star's remains are heated up. But this particular event, known as Assassin 14 Li, stands out for several reasons. At the time of its discovery, back in November 2014, it was the closest tidal disruption event to Earth, just 290 million light-years away, to have been discovered in around a decade. Because of this proximity, Assassin 14 LA has provided an extraordinary level of detail about the destroyed star. Miller's team applied new theoretical models to make improved estimates on the amount of nitrogen and carbon around the black hole. The relative amount of nitrogen to carbon found points to material from the interior of the doomed star weighing about 3 times the mass of the Sun. The star Assassin 14 Li is therefore one of the most massive, perhaps even the most massive star that astronomers have ever seen ripped apart by a black hole. One of the hardest things with tidal disruption events is being able to measure the mass of the unlucky star being destroyed. Observing the destruction of a massive star by a supermassive black hole is spellbinding because high-mass stars are expected to be significantly less common in the cosmos than lower-mass stars. Now, you may recall that earlier this year, another team of astronomers reported on Scary Barbie, another tidal disruption event. Now, at the time, they estimated that the star at the center of that could have been up to 14 times the Sun's mass before it was destroyed by the black hole. However, there are a number of problems with this. Firstly, it still has not as yet been confirmed as a tidal disruption. The estimate of the star's mass mainly based on the brightness of the flare, not on the detailed analysis of material around the black hole, as is the case with Assassin 14 Li. A report in the astrophysical journal Letters suggests another exciting aspect of Assassin 14 Li's result is what it means for future studies. Astronomers have seen moderately massive stars like Assassin 14 Li in the star cluster which orbits around Sagittarius A star, the supermassive black hole at the center of our own Milky Way galaxy. That's just 27,000 light-years away. Therefore, the ability to estimate stellar masses of tidally disrupted stars potentially gives astronomers a way to identify the presence of star clusters around supermassive black holes in far more distant galaxies as well. Until this study, there was a strong possibility that the elements observed in X-rays might have come from gas released by previous eruptions of the supermassive black hole. However, the pattern of elements analysed here appears to have definitely come from a single star. And that makes it intriguing. This is SpaceTime. Still to come, the launch of a new window on the X-ray cosmos. And astronomers find a hot Jupiter, or is it really a brown dwarf, hotter than the surface of the Sun? All that and more still to come on SpaceTime. Japan's about to launch a new X-ray telescope which will further enhance science's understanding of the universe. The upcoming XRISM X-ray imaging and spectroscopy mission spacecraft will study the universe's hottest regions, some of its largest structures, and objects with the strongest gravity. Led by the Japan Aerospace Exploration Agency JAXA, XRISM will peer into these cosmic extremes using spectroscopy, the study of how light and matter interact. The heart of the spacecraft is XRISM's microcalorimeter spectrometer, named Resolve. It's a collaboration between JAXA and NASA. It will create spectrum measurements of light's intensity over a range of energies for X-rays from 400 to 1200 electron volts. Now, by comparison, visible light energies range from about 2 to 3 electron volts. Now, to do this, Resolve measures tiny temperature changes created when an X-ray photon hits its 6 by 6 pixel detector. Current instruments are only capable of seeing these fingerprints in a comparatively blurry way. But Resolve will be effectively providing a magnifying glass for scientists studying X-ray spectrometry. To measure that minuscule increase and determine the X-ray's energy, the detector needs to cool down to around minus 270 degrees Celsius, just a fraction of a degree above the minus 273.15 degrees Celsius, which is absolute zero. Now that's 20 times colder than the Boomerang Nebula, the coldest known natural environment, and about 50 times colder than the temperature of deep space, which is warmed only by the oldest light in the universe, the cosmic microwave background radiation. Resolve will reach its operating temperature following a multi-stage mechanical cooling process inside a refrigerator-sized container of liquid helium. XRISM's principal investigator, Richard Kelly from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says the Resolve instrument will let astronomers peer deep into the makeup of cosmic X-ray sources, venturing inside to a degree that hasn't been possible before. Kelly says scientists anticipate many new insights into the hottest objects in the universe. These include exploding stars, black holes and the galaxies powered by them, and even entire clusters of galaxies. And that's because Resolve will help astronomers learn more about the composition and motion of extremely hot gas within clusters, near light-speed particle jets powered by black holes in active galaxies, and other cosmic mysteries. See, the Webb Space Telescope is capturing similar spectra, but for infrared light. And Webb spectra has revealed the makeup of gas near active black holes, and it's mapped out the movement of the material towards and away from the viewer. Data from XRISM's Resolve instrument will do the same thing but at higher energies, thereby helping paint a fuller picture of these objects. XRISM's other primary instrument is Extend, which was developed by JAXA and Japanese universities as an X-ray imager that will perform simultaneous observations with Resolve to provide complementary information. Both instruments are relying on two identical X-ray mirror assemblies which were developed at Goddard. In this report by NASA TV, Sophia Roberts from NASA's Goddard Space Flight Center in Greenbelt, Maryland, explains how understanding spectroscopy deepens science's knowledge of the universe.
Astrophysics is much more than just capturing different wavelengths of light. Many objects or phenomenon are simply too far away to directly image. A lot of data comes from pixel-sized point sources, and those points provide astrophysicists with a powerful window into what makes up the universe. Even now, most of what scientists learn about the cosmos comes from studying light. Astronomers can work out distances, speeds, sizes, temperatures, and the composition of elements because matter behaves in predictable and consistent ways. They do this by literally prying these photons apart. This is spectroscopy. Spectroscopy is the study of how matter interacts with light. And it all began with a prism. Light entering one side of the prism bends or refracts as it passes through the triangle shape and exits out the other side. All of the wavelengths enter together, but they exit as a rainbow-like spread of colors. What's happening is that the shorter, more energetic wavelengths, like blue and violet, bend a little more than the longer, lower energy light, like red and orange. Because they bend at slightly different angles, the wavelengths separate, fanning out into a band of colors. NASA has a whole fleet of telescopes that can split and study a wide range of light on the electromagnetic spectrum, not just the light that our eyes can detect. So Hubble can detect through the visible spectrum, but also a bit into the infrared and the ultraviolet. Webb is just infrared and can look at the light that is emitted from billions of years ago. And of course, the images from Webb are really spectacular. This spectrum shows a light that penetrated the atmosphere of a planet called WASP 96b. The light being measured comes from the planet's host star, some of which skims through the atmosphere. Humans are a long way from directly imaging exoplanets, so telescopes like Webb will use spectroscopy to find those chemicals that could support life in their atmospheres. Which is why Webb's first spectra is so amazing.
You're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
But it's one thing to identify single elements or simple molecules, but deciphering whole foreign bodies like Dr. Owajawek. How do you know?
Oh my God, it took us a very long time to figure this out. It really took us many, many decades, and it took us many, many fantastic new instruments.
If all of our astrophysical objects or anything that we're looking at were made up of one element, this would just be so easy. But we don't. So we have to do experiments on Earth to prove what we're looking at looks like what we are thinking we're looking at. So in here is argon. It glows this really pretty purple. And then if we look at it with a spectroscope, it shows us a very specific fingerprint to argon. These are called spectral tubes. They contain the gas of one element, and the box runs a voltage through the tube. When I turn on the switch, the charged gas turns to plasma and emits a color that is unique to that one element. It also makes unique lines when you look through the spectroscope. This same process happens in a star or a hot region of gas. So we use tubes like this to verify what we see in space. If you do a quick search for spectroscopy data, there are numerous ways that the data can appear. Those variations are based on the source of the cosmic light. There are 3 types of spectra that we can use: continuous, emission, and absorption. Light from a hot, dense source, like the sun, produces a continuous spectrum. When that light passes through cooler gases on its way to us, the gases take away or absorb some of that energy. Dark lines appear where specific colors are missing. And when thin gases glow themselves, we see only their characteristic colors, kind of like a cosmic barcode. These are the emission spectra. Like all data, there is an art to analyzing spectra. Scientists like Dr. Owajawek use computers to calculate and tease out clear signals, comparing them then to models that are already known.
Many scientists in the labs on Earth, they try to recreate the same conditions and measure basically what these kind of, as you said, fingerprints of those different transitions for different elements are.
Okay, so we're always comparing to sort of the fingerprint of what we have, and then if it has deviated from that, that is the new information from what we're looking at.
Correct.
For Anna, spectra unveil the structures of black holes, the swirling winds that surround them, and those big jets of particles that come out of them.
So all of this is mostly accretion disk at this level. It's just different parts of it. We can zoom in, right? And we see all of the absorption lines, right? All of these lines are also shifted a lot. So they come from this wind. So that's how we know that there is winds blowing around black holes.
The same principles apply no matter the wavelength of light. But each wavelength of light tells us a little something different about each character we find in the universe. It's pretty wild how different the universe looks to our eyes and how it presents to our telescopes. And that's precisely why we need to observe in different wavelengths of light. Modern astronomy is built upon spectroscopy. So with every stream of light we gather, we further understand what the universe is made of. All we need to do is pry open its contents.
That's Sophia Roberts from NASA's Goddard Space Flight Center in Greenbelt, Maryland. And this is SpaceTime. Still to come, discovery of a hot Jupiter, or is it a brown dwarf, hotter than the surface of our sun? And later in the science report, a new study warns that emperor penguin colonies in Antarctica are experiencing complete breeding failure due to climate change. All that and more still to come on SpaceTime. Astronomers have discovered a hot Jupiter, which has now turned out to be a brown dwarf hotter than the surface of our sun. The search for exoplanets, planets which orbit stars located beyond the borders of our solar system, has always been a hot topic in astrophysics. Of the various type of exoplanets, one is the hot in the literal sense hot Jupiter, a class of exoplanets that are physically similar to the gas giant Jupiter in our solar system, but instead of orbiting their host stars out beyond the snow line as Jupiter does around the sun, hot Jupiters orbit very close into their host stars, often completing a full orbit in just a few days or even hours. And, as their name suggests, they wind up becoming extremely hot. Because of their unique environments, they hold a fascination in the astrophysics community. But the problem is they're really difficult to study because the glare of the nearby star makes them hard to detect. Now, a report in the journal Nature Astronomy looks at the discovery of a system consisting of what appear to be two celestial bodies located about 1,400 light years away that together appear to provide an excellent opportunity for studying a hot Jupiter environment, as well as advancing science's understanding of planetary and stellar evolution. The discovery of this binary system, the most extreme of its kind known so far in terms of temperature, was made through analysis of spectroscopic data gathered by the European Southern Observatory's Very Large Telescope in Chile. The study's lead author, Naama Halkoon from Israel's Weizmann Institute of Science, says they identified a star-orbiting hot Jupiter-like object that, based on their readings, was the hottest ever found, with a surface temperature around 2,000 degrees Celsius hotter than the surface of our Sun, which is around 6,000 degrees Celsius. But she says that unlike the glare-obscured hot Jupiter planets, it was possible to see and study this object because it's really large compared to its host star. A white dwarf some 10,000 times fainter than a main sequence star. That makes this the perfect laboratory for future studies of hot Jupiter's extreme conditions. Now, let's define some terms here. White dwarfs are the stellar cores of sun-like stars that have used up all their core hydrogen and helium fuel supplies, ceasing core nuclear fusion, the process which makes stars shine. Their outer layers will eventually blow off, leaving behind and exposing just their white-hot stellar core, a white dwarf, usually around the size of the Earth, which will slowly cool over the eons. Now, in this case, the other part of our binary system, the hot Jupiter, turns out to actually be a brown dwarf. Now, brown dwarfs are failed stars lacking enough mass to commence the core nuclear fusion process in the first place. However, unlike gas giant planets, brown dwarfs are massive enough to survive the pull of their stellar partners. See, the enormous mass of a star means its gravity can cause objects to get too close to break apart. But this brown dwarf's also really dense, some 80 times the mass of Jupiter, all squeezed into an object no larger than Jupiter. With that sort of density, it's able to survive intact and form a stable binary system with its host star, the white dwarf. When two bodies, be they a star and planet, or in this case a white dwarf and brown dwarf, orbit really close to each other, the differential forces of gravity acting on the near and far side of the brown dwarf cause its orbital and rotational periods to become synchronized. Now, this phenomenon is known as tidal locking, and it permanently locks one side of the planet in the position that always faces the star. Now, we see the same thing here on Earth, with the moon always having the same face, what we call the near side of the moon, always facing the Earth. Tidal locking leads to extreme temperature differences between the day-side hemisphere, which is bombarded by direct stellar radiation, and the far or outward-facing night-side hemisphere, which receives a much smaller amount of the radiation. The intense radiation from their stars causes hot Jupiters and even brown dwarfs extremely high surface temperatures. And the author's calculations, based on an analysis of the brightness of the light emitted from the system, suggest the orbiting brown dwarf's dayside surface temperature is somewhere around 7,000 to 9,500 degrees Celsius. The temperature on the night side of the brown dwarf is still hot, somewhere between 1,000 and 2,700 degrees Celsius. And all that results in an extreme temperature difference of around 6,000 degrees between the dwarf's two hemispheres. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that emperor penguin colonies in Antarctica are now experiencing complete breeding failure as a direct consequence of the unprecedented loss of sea ice recorded in the region in recent years due to climate change. A report in the journal Communications, Earth and Environment used satellite images from 2018 to 2022 to monitor emperor penguin colonies in the Bellingshausen Sea region of Antarctica, finding that 4 out of the 5 colonies there saw absolutely no chicks survive to fledge successfully during the spring of 2022. Emperor penguin colonies generally need stable ice attached to the land between April and January to ensure successful breeding and molting. That's because the chicks don't develop waterproof feathers until fledging. This is the first major breeding failure of emperor penguins observed during 13 years of observations in the region, and it's amongst the first evidence of the direct impact of Antarctic warming on the viability of emperor penguin populations. A new study has recommended mask wearing should continue in healthcare settings. The findings, reported in the journal The Annals of Internal Medicine, argues that the infection of SARS-CoV-2 is still a threat, especially to the most vulnerable patients, and that masks, if worn correctly, are a proven method of preventing transmission. The authors of the commentary say both patients and healthcare professionals should draw upon lessons learnt during the height of the COVID-19 pandemic and continue to mask up, as severe outcomes attributable to COVID-19 are still occurring. The problem is many healthcare workers still come into work with COVID-19, both symptomatic and asymptomatic, and pre-pandemic sick leave policies and more limited testing options are making healthcare workers more likely to work even though they're sick. Researchers say they've found absolutely no link in the country's uptake of Facebook and its population having poorer mental health. The findings, reported in the journal The Royal Society Open Science, used well-being data from close to 1 million people across 72 countries over 12 years and compared it with individual usage data from millions of Facebook users worldwide. They say their data doesn't support the idea that social media was bad for mental health. And in fact, if you follow the right blogs and websites, it could be related to positive well-being. Samsung tops the list of complaints, possible delays in some next-generation iPhones, and new updates for people running Windows on their Macs. With the details on all these stories and more, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Well, this comes from the New South Wales Fair Trading Commission, and they've released the top 10 list of most complained about businesses in 2023. Samsung has topped the list with 416 complaints from January to June 2023, and the common issues were the quality of goods, the supply of goods and services, the conduct of the company, the request for a refund, and warranty rights and remedies. But lest you think that they're the only technology company in the list, Apple comes in at number 9 with 103 complaints, so 4 times fewer complaints. The issues of quality of goods, quality of service, and repairs and maintenance. Number 10 on the list is Good Guys with 75 complaints. And there's also people like Ticketek and True Water, a water filtration company, and a bunch of other ones there.
And there are delays in the new iPhone 15. Tell me.
Yeah, an analyst says that the iPhone 15 Pro Max, which is the biggest version with the biggest battery and the most cameras and the biggest zoom, this is expected to be 3 to 4 weeks delayed compared with the rest of the iPhones because of a sensor issue where Sony just can't make enough of the camera sensors for Apple in time. And look, it's not the first time we've had delays. The iPhone 10 came out a couple of months after the iPhone 8 several years ago. There were delays with the iPhone 12 mini and the iPhone 12 Pro Max. So it's not the first time, but it will push out some of those sales. Look, it'll all happen in the same quarter still, which is important for yearly sales figures. The December quarter obviously is the biggest one that they have every single year because of all the Christmas and sales and holiday shopping season and people finally upgrading their iPhones. And of course, if you're upgrading from an iPhone 8 or a 10 or even an 11 or 12, you're going to see big jumps this year in terms of the camera quality, and especially with the iPhone 15 Pro Max, we expect to see a periscope zoom, which will hopefully be 5 or 10 times like we see on the Samsung phones, which have 10 times optical zooms.
And the Parallels desktop software's had some changes.
Yes, this is Parallels Desktop 19. This is a new version. This is the software that is used to run Windows virtually on your Mac. And for many years now, it has been out. It's been getting improvements every year, able to run more games, more graphical programs, letting you run Word, Excel, PowerPoint, the Windows versions on your Mac desktop. You can either have the desktop as a separate desktop, or you can just run Windows programs on the Mac desktop as though they were another Mac program. Now, improvements this year are that you can use your Touch ID if your Mac has one to log into Windows in a passwordless way. And there's improvements to graphics, but you can also run older versions of Windows, other versions of Mac OS, versions of Linux, and it's just the most efficient way to have multiple operating systems on the same Mac. And of course, if you buy a Mac that has 16 or 32 gigs of memory and plenty of space on the SSD, then you don't have to worry about the various operating systems slowing down whilst you're trying to run several of them at the same time. And I often say that running Windows on a Mac using Parallels desktop software is actually better than running Windows by itself on a regular PC. So it's really good stuff. It's about $99 a year to upgrade, and give it a go if you need to run Windows programs on your Mac. And you can find more information about all those stories at techadvice.life. And I've also got information on Nintendo's Charles Martinet, the voice of Mario, retiring. There's NBN has released uncapped satellite plans for people in rural and regional Australia. The AI hype has been analysed by Gartner, who says that generative AI is at the peak of inflated expectations. You can learn more about that there. And look, there's tons more. So please check out techadvice.life when you can, and have a great day.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.